Welcome everybody. This is 4.3 graphs of quadratic functions. So today we will learn characteristics of a quadratic function and its graph and complete the square to put it into vertex form to find the vertex and find a bunch of other goodies that we will cover. So a lot of work for these problems. Okay, so let's get started. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and the leading coefficient a cannot be 0. The domain of a quadratic function is the set of all real numbers. All right, so here are some parabolas, which is the graph of a quadratic function, and some of their characteristics. So the first one we see is a parabola that opens up, right? This opens up. So we open up, right? And some things to note about this parabola. One of the most important things of the parabola is the vertex. That is the main point of the parabola. And then the next thing is your axis of symmetry, which is the vertical line that cuts straight through your parabola. So what's great about the axis of symmetry is, well, if you flip the parabola over on either side, it is very symmetric, meaning if I have a point to the left of the axis of symmetry, then I can just reflect that point over the axis of symmetry and have the same point, right? So you can reflect points across it. Okay, another thing to notice is we see that you have X intercepts. Well, this example has 2 X intercepts. Sometimes parabolas have 2 X intercepts, 1 X intercept, and sometimes they may not have any X intercepts. So keep that in mind. But one thing a parabola will always have is a Y-intercept. Parabolas have one and only one Y-intercept. Okay, so these can cross, so these can have 2 X-intercepts, 1 X-intercept, no X-intercepts, but they will always have 1 Y-intercept. Okay. And some other things to note, just like we said in the above, the domain of any parabola or quadratic function is always all real numbers. The range for a parabola that opens up will start at the y value of the vertex. So it'll start at bracket y, and then these tails head towards positive infinity. So the range will start at the y value of the vertex and head towards infinity. And then as well, a parabola that opens up will also have a low point. And remember what that low point is called? If a graph has a low point on it, it is called a minimum. And you will have a minimum at the y value of the vertex. Okay, because the vertex here is also the low point. All right, now let's look at the other parabola. This is a parabola that opens down. This one opens down and has the exact same characteristics as a parabola that opens up. So once again, your main point, the vertex. A y-intercept. And this example again has 2 X-intercepts, but remember, a parabola can have 2 X-intercepts, 1 X-intercept, or no X-intercepts. You have the axis of symmetry. So everything's still there. You can still reflect points across it. And the domain is still all real numbers. The range for a parabola that opens down will start at negative infinity because these tails head towards negative infinity. And as we come up, we have to stop at the y value of the vertex. There it is. And one last thing, if your parabola opens down, you create a high point at the vertex. And a high point on the graph is known as a maximum. And that max will happen at the y value of the vertex. All right. Okay, so those are correct characteristics of parabolas. And the table below is just going to verify more of that information. So the form, what we're going to be doing today is we will be given the standard form of a quadratic function. And then our job is to complete the square on it and put it into vertex form. So we need to go from standard form to vertex form, and to do that, we will complete the square. We did it in the last section as well. So, but in the last section, we completed the square, we put it into vertex form, and we only graphed it by transformations. So today, we'll graph it a little differently without using transformations, because we want to get all the pieces of the parabola. All right. So there's one part. So we will ignore this part for right now. So just ignore this part. We'll come back to that in a second. Maybe at the end of the notes. Maybe, right? All right. So once you put this into vertex form, once you put your quadratic function into vertex form, then it is easy to see that your vertex is given by HK. So your vertex is always the point HK. That would be HK as well. And then to find the axis of symmetry or the line of symmetry, that formula is X equals H. So one thing is for sure, if you know the H value of the vertex, then that is the same H value as in the line that you'll use for the axis of symmetry. So those H's go hand in hand, okay? All right. And then there's some things that we know already. To find a y-intercept, you let x equal 0 and you solve for y. We know this already. To find a y-intercept, you let x equal 0 and you solve for y. To find an x-intercept, we know how to do that as well. You let y equal 0 and you solve for x. And you do that by factoring, completing the square, and the last thing we would want to use is the quadratic formula. So that's how we solve for x. And you'll get your x-intercepts. Okay, so down below we have something called the discriminant. I won't use it, but use it if you want. It's only helpful in telling you how many x-intercepts you have, but it doesn't find your x-intercepts. So I just think it's just an extra formula, an extra process that we don't need to use, but use it if you want to know how many intercepts you have. So the discriminant is that formula b squared minus 4ac. So when you plug in the values of b, a, and c from your quadratic function, if the values are greater than 0, then you'll have 2 x-intercepts. If it's equal to 0, you'll have 1 x-intercept. And if it's less than 0, you have no x-intercepts. So truthfully, it's only really useful for the third one, because if you say, hey, this doesn't have x-intercepts, then you don't have to worry about finding x-intercepts. But if you found out that, hey, this has 2 or 1 x-intercepts, guess what? You still have to go find those x-intercepts. So why not just find them from the beginning? Just up to you. I'm not going to use it, though. I hate adding more formulas to anything else we have learned. So that's no fun. All right. A quadratic function has a max at the vertex if a is negative. So what that means is that if you look at the very top and look at the quadratic function, this says if the leading coefficient is negative, so if I put this here, if a is less than 0, meaning negative, then you will have a maximum and your parabola will open down. Oh, I didn't even see that was written there. Oh, well, twice, even better, right? Burn it into your brain. And then the next part says if a is positive, meaning if a is greater than 0, if the leading coefficient is greater than 0, then your parabola will open up and your parabola will have a minimum. That's all that says. Okay. And then range, we went over it. If you have a maximum, then your range is negative infinity to y. Hey, look, that's what we did. Range, negative infinity to y. Oh, that's big. And if you have a minimum, your range is y to infinity. Once again, everything we have figured out already. It's all there. So these are the characteristics of a parabola, and this is everything we are going to find. One more thing, because this is what I don't have in my notes, because my math lab likes to throw curveballs. And if my parabola opens up, this is also considered concave up. And if my parabola opens down, this is also considered concave down, just because they want you to know concavity. Okay, so let's get started. Given the function x squared minus 8x plus 12, find the vertex form, find the vertex, the axis of symmetry, the intercepts, graph it, find concavity, max or min, domain and range, intervals of increase or decrease, and determine where the function, where the y values are above the x-axis and where the y values are below the x-axis. Man, that's a lot, right? Okay, let's get started. How much can I zoom in here? Right there, that's perfect. Let me use all my room. What's the function? X squared minus 8x plus 12. So we'll say A. X squared minus 8x plus 12, right? Writing it down is helpful, okay? So now our job is to put this into vertex form by completing the square. And remember, to complete the square, you must have a perfect form where the leading coefficient is 1, right? To complete the square, we need to have x squared plus bx plus c. And if that leading coefficient is 1, we are good to go. Which means let's go ahead and complete the square, which means we'll take half of negative 8, square it, get negative 4 squared, and we get 16. Okay, and now since this is a function, not an equation, this is a function, we have to add and subtract that number on the same line. So you'll get f of x equals x squared minus 8x plus 16 minus 16 plus 12. And now, we combine these three terms together because that's our perfect square trinomial. Factor, simplify. So f of x will give me x minus 4 times x minus 4 minus 4. Finish it up. And we have f of x equals x minus 4 squared minus 4. Boom, boom, boom. There it is, vertex form. Okay, and then we can find the vertex. So that's B. The vertex is given as HK. So remember that from the above, that's x minus h squared plus k. Now, whenever you state h, you always state the opposite because you have to think of it as a transformation. X minus 4 is a horizontal shift to the right. So this means that for my vertex, HK, we are going to get, for my H value, since that says negative 4, we always think opposite. My H value is just going to be 4. Because once again, by transformations, if you had the parent function at 0, 0, you would shift it to the right 4 spaces. And then for my K value, remember, this is a vertical transformation, and vertical transformations are straightforward. So this means we have 4, negative 4. Oh. And there's our vertex. Next is easy money, easy money. It is the axis of symmetry, which is that vertical line that cuts straight through the parabola. It's x equals h. Well, since our h value is 4, this means we get, oops, x equals 4. That's simple. If you know h, you know the value for the axis of symmetry as well. Okay. Nope. Stop it. There we go. All right, we're working our way down the list. I got a lot of room. Okay. Vertex form, vertex, axis of symmetry. Next is intercepts. So here's where we put in that work, right? All right. So D. Let's go for X intercepts. To find the X intercepts, you let Y equal 0. Remember, f of x and y are the same exact thing. Okay, so what I'm going to do is take the vertex form and set that equal to 0. So I'm just going to take x minus 4 squared minus 4 and set it equal to 0. X minus 4 squared minus 4. Okay, good. And just solve for x. Add that 4 over. Square root both sides. And x minus 4 equals, and remember, very important, don't forget your plus or minus. Add that 4 over. And then add the 4, or add the 2 and subtract the 2. So we're going to get x equals 4 plus 2, which will give me 6, and x equals 4 minus 2, which gives me 2, which translates into 6, 0, 2, 0. These are the x-intercepts. Now let me show you something really fast, because we didn't have to use the vertex form. I could have used the original function before we put in the vertex form of x squared minus 8x plus 12, set it equal to 0. And if it's factorable, we'll factor it. And this one's definitely factorable. This one gives me x minus 6, x minus 2 equal to 0. And I get x equals 6, x equals 2. Same exact thing there. But I don't like to bounce around from let's put it in vertex form, but then let's use this form, but then let's go back to vertex form, and let's just switch back and forth. I like to keep it uniform, but I am also showing you, in case it makes your life easier, I'm showing you that, hey, you can actually factor that and probably make the work a little simpler. But use it if you want. We get the same answer. So it doesn't matter technically, right? But that's it again, right? Showing different methods, we get the same answer. I just want to keep everything uniform. All right. Y-intercept, I'll just do right next to it. Y-intercept, we let x equal 0. And let's just use the vertex form again, because I said, let's keep it uniform, but then I'll show you the other way as well. So that means I'll get f of 0 equal to 0 minus 4 squared minus 4. I'm just plugging it in to that vertex form that we found. So 0 goes in for x, subtract 4 squared minus 4. And then f of 0 gives me 16 minus 4, which gives me 12. Which then gives me a y-intercept of 0, 12. Okay, shortcut time. Go to the very top. Right here. To find a y-intercept, you let x equal 0. Here's the fastest way to do it. Plug in 0, and guess what happens? This becomes 0, this becomes 0, and we're left with 12. That is exactly what we found below. So fast, right? Like I said, I'm just keeping everything uniform. I don't want to say, let's bounce back here, let's bounce back here, let's go here, let's go here. I'm just keeping it uniform, but I'm also, again, showing you another way to get it. And that one is a lot faster. You're welcome. Okay, vertex form, vertex, axis symmetry, intercepts, graph it. All right, let's graph it. Okay. What was I going to say? 3 points needed to graph a parabola. 3 points. One of the main points that we need is the vertex. And then another point can be the y-intercept. and then the other point can be the x-intercept. As long as I have 3 points, a point to the left of the vertex and a point to the right of the vortex, we can graph our parabola. 3 points are needed. Okay. So let's go ahead and plot. I will put down, see up there in this color. And first thing I'll plot is the vertex at 4, -4. 4, -4. Right there. There's my vertex. And then I'll plot my x-intercepts, which are at 6, 0, 2, 0. 2, 0, 3, 4, 5, 6, 0. And honestly, that's all the points we need. I have a point to the left of the vertex, and I have a point to the right of the vertex. 3 points to make a parabola. But then I have a y-intercept, so let's plot it. No, it's 0, 12, it won't fit, but it would go somewhere up here. So sure, I'll plot it there. Okay. That's all we need, so let's connect. No, I'm trying to make it pretty. Pretty as it's gonna get. Okay, there's the graph, and now let's figure out the rest of what it's asking. It wants concavity. Well, we see that this graph opens up, so let's put all this stuff down, right? Let's write this down. Opens up. Actually, I got room down below, right? There you go. Opens up, which means if it opens up, it is concave up. Since it opens up, the vertex is now my minimum. So we have a minimum at the y value of the vertex. So minimum at y equals -4. Unless my math lab wants you to state the point, then just state the vertex. But if not, just say you have a minimum at y equals -4. Or maybe it just says at -4. I think I'm going to say y though. Okay. So we have concavity, max, min, domain. That's a giveaway. So domain is always all real numbers. Let's keep writing it here. And then range. Since this parabola opens up, we have to start at the y value of the vertex, which is bracket -4. And since it opens up, since these tails go upwards, we are headed towards infinity. Domain, range, intervals of increase, decrease. Oh my goodness, we want so much information. So let's come here. Remember, for intervals of increase and decrease, we read the graph from left to right. And I'll put the x value here. This is at 4. So we see from -infinity to 4, the graph is decreasing. So for my decrease interval, that's from -infinity to 4. And I think my math lab wants brackets, right? And then my increase, look at it again. From 4 to infinity, the graph is now increasing. Should be parentheses on those, but you know, whatever. Okay. Intervals increase, decrease. The last question is, where are we above the x-axis and where are we below the x-axis? What intervals of y, I mean of x, of y is greater, right? So let's answer that. I can do that down here. Give me more room. Let's look at that. Sorry, trying to make this better. Stop it. Where is f of x greater than 0? So remember, this means where are we? What intervals are we above the x-axis? And once again, we only state x values. So where are we above the x-axis? And that would be here and here. So how do we state that as x intervals? Well, we'll say from negative infinity to this first x value, which is 2, union, we start again at this x value, which is 6, and head towards infinity. That's where we are above. And then the last one wants to know, where are we below the x-axis? And that's everything down here. That's where we are below. So this is just going to be from 2 to 6. Now look at the notation here. They all have parentheses on them. If this said greater than or equal to or less than or equal to, all of these would have brackets. Okay. All right. There's the first one. Wasn't too crazy, right? Yeah, sure. On to the next one. Let's do it again. Super zoom, there we go. Use all the room I can for these ones. And let's do it all over again for this function. A. Negative 4x squared minus 6x plus 2. All right. First thing we go for is the vertex form, which means we need to complete the square. But is this in the perfect form? And that answer is no. We have to factor out that negative 4. So f of x equals, I take the negative 4 out only from these two terms. right? We take the -4 only from those two terms. Okay. Which leaves me with positive x squared plus, because -4 from -6, negative over negative becomes positive, and that leaves me with 6 over 4x plus 2. All right. And again, check your work to make sure you're doing it right. Remember, factoring is essentially dividing that term from every number. So when I say that, I mean when you take -4 from -4x squared, you end up with x squared. When I take -4 from -6x, I end up with positive 6 over 4x, which can reduce. So let's write the reduced form. X squared plus 3/2 x plus 2. Ooh, this is going to be ugly, right? All right. So now we are in the perfect form, or the inside polynomial is in the perfect form to complete the square, because now that leading coefficient is 1. So let's CTS. Oh yeah. 3/2 over 2 squared. We take half of 3/2. Oh my goodness, right? Which means that this becomes 3/2 times, and if I put this 2 over 1, you would multiply by the reciprocal, which gives me 1/2. And we're still squaring it. And then you get 3 over 4 squared, which then gives me 9 over 16. All right. Making sure I'm not messing anything up. 3 over 4, okay. All right. Now come back to our function. And for this one, it's going to be a little tricky, right? I'm going to rewrite it as x squared plus 3/2 x plus 9 over 16 minus 9 over 16 plus 2. And for this one, we will factor these 3 terms, because remember, when you complete the square, these 3 terms create the perfect square trinomial, which is factorable. Brackets for neatness, and you'll get x plus a number, x plus a number, minus 9 over 16 plus 2. All right, keep that red. Keep this red. Now, how do you factor that trinomial? Well, remember the trick. What number did we square? We squared 3/4. So that's going to go here and here. Too easy, I tell you. All right, there, and f of x equals -4. Keep that bracket there, because now you have x plus 3/4 squared minus 9/16. Keep that in red. The other one is fine now. I won't put that 3/4 in red because we factored it now. Plus 2. Okay. Take this -4 and distribute. And f of x equals -4 times x plus 3/4 squared plus -4 times -9/16. So that's going to be a plus, right? And -4 times -9/16 should give me a positive 9/4 plus 2. 9/4 plus 2. 4, that's 1. That's 4, that's good. And one final cleanup. Oh my goodness, right? We get f of x equals -4 times x plus 3/4 squared plus 9/4 plus 2. 2 times 4 is 8. And 8 plus 9 is 17. Which gives me 17/4. Or put 2/1 multiplied by 4/4. That'll give you 9/4 plus 8/4, which is 17/4. And after much trouble, we get vertex form. Which means now the easy stuff comes, right? Vertex -3/4, 17/4. Axis of symmetry. X is -3/4. Time for some work. X intercept is f of x equals 0. So we get. Okay. Oh. And we get, what do they have? X plus 3/4 squared plus 17/4 equals 0, right? Is that the right formula? Oh, -4. Don't forget that. -4 times x plus 3/4, so 17/4 equal to 0. So I'm sending that equal to 0, and we're going to solve. Okay. First thing, I wrote it down right? Yes. Okay. Move that 17/4 over. And then multiply both sides by, or divide by -4. I'm just going to make it easier and say multiply both sides by the reciprocal of -4, which is -1/4. It's the same as dividing. Multiply both sides, because if you divide, you still have to multiply by the reciprocal on the right side. So divide by 4. And we get positive x plus 3/4 squared equal to positive 17/16. And then square root. All right. And then you'll get x plus 3/4 equal to plus or minus the square root of 17 over 4. All right. And then we'll have x equals negative 3/4 plus or minus the square root of 17 over 4. And do we really want to graph those? No, but it is also important on how to actually find those. So let's look at our x-intercepts. I'll rewrite this as x equals negative 3/4 plus square root 17 over 4. And x equals negative 3/4 minus square root 17 over 4. Calculator time. All right, so let's see. Taking quit, myself over here. Okay, well, I'm going to use this TI-30XS, which is nice and fancy. Not fancy, but it's good. And I'm going to type in the fractions we have. Fraction button, negative 3/4 plus fraction button, second square root 17 over 4. And that gives me a simpler form, but I will hit these double arrows above the enter button, and I get 0.28. Oops, wrong spot. 0.28. And then, let me go back up. I'll hit enter on that. And then I'm just going to change this to, never mind, I'll just rewrite it all again. Negative 3/4 minus square root 17 over 4. Rewrites it, and double arrow, and negative 1.78. Okay, those are your x-intercepts. Just terrible, I know, but it was worth the process. The calculator process. Which means we have x-intercepts at 0.28 and 0, and negative 1.78 and 0. Whoa, buddy. All right. Now on to the y-intercept. And now, since that took forever, yes, let's use the other version. Cheat codes, right? Let's look at this. This is going to make life a lot easier, right? If I plug in 0 here, well, guess what? 0, 0, and we're left with the y-intercept of 2. Oh, aren't y-intercepts so much easier to find? There it is. So we get 2, and that's what I'll write right there. Boom, done. Oh, I never drew the axis of symmetry in the last one, did I? Real quick. It's just the line that cuts straight through the parabola. There it is. That's your axis of symmetry. All right, back to the other one. Oh my goodness, we're doing so much work. And now it's time to graph. All right. Which means that we probably want to put these into decimal form, which is -0.75, and 4 goes into 17. I'm going to guess 4.25 times. I'll use this calculator for that. 17 over 4, 4.25, perfect. Okay, now let's graph. And we don't have to be too accurate. You might have to be, but I'll just put the points where I think they might go. So let's see. So we're at -0.75 and 4.25. So -0.75 and 1, 2, 3, 4. Let's say we're right there. There's my vertex. And then look at my X intercepts. .28, oh boy, and -1.78. So let's see. So 0.28 is basically right there, and -1.78, basically almost touching 2. And that's fine. And then my Y-intercept is at 2. Hey, that point's perfect. And now we can graph. Oh boy. It's gonna look ugly. Not so crooked. There you go. Something like that. All right. So it opens down, and then we have all that lovely stuff figured out. My axis of symmetry, of course, cut straight through it. There's x equals -3/4. And then let's figure out all the other questions. What were they? Concavity, so this opens down, so we have concave down. Concave down, max min domain. It opens down, so we have a max. There's a max at y equals 17/4 or 4.25, whichever answers. Domain and range. That's easy. -infinity to infinity. Range, a little different. This opens down, so we start at -infinity, and we end at the y value of the vertex, which is 17/4, bracket. And then intervals of increase, decrease. So from the -infinity all the way to the x value of the vertex, which is -3/4, we see that the function is increasing. So we increase from -infinity to -3/4, close bracket. And then from that x value, to infinity, we see that the function is decreasing. And last is, where are you above the x-axis? Where are you below the x-axis? So I'll just put that. I can fit all of that right here. Why not? Where are we greater than 0? Oh boy, that's from this x value to that x value, because all of this graph is above the x-axis. So that was what? From negative 1.78 to 2, not 2, to 0.28. And where are we below the x-axis? And that's all of here. So that would start at negative infinity and stop at the first x-intercept of negative 1.78, union, start back at the second x-intercept of 0.28, and head towards infinity. And that's it. Oh, that was brutal, huh? All right. Oh, let's hope I didn't mess up anywhere. You can always double check it on Desmos. Let me see. Yeah, we can do a quick check. Let's see. My browser open. I'm already on Desmos. Negative 4x squared minus 6x plus 2. There it is. Looks a lot better than mine. And there's the y-intercept at 2. And then here's my x-intercepts at 0.28. All right. And negative 1.78. Love it. I'm good. We are good. Well, I'm good. I did it. All right. All right, look at that. That's good to double check, right? You still have to figure out all this information by hand, because that's what I'm going to want to see on the test. No shortcuts, people. Okay, that is graphing quadratic functions, putting them in vertex form and finding all the pieces and all the information that these questions want. All right. Last page. The graph of the function f of x equals ax squared plus bx plus c has its vertex at 1, negative 5, and has a y-intercept at negative 3. Find the value of a, b, and c. All right. Well, if they're giving us the vertex, then it would probably be wise to actually use the vertex form that we've been learning, because there's nowhere else to plug that into, right? Other than plugging in for x and y. Okay. Yeah, that would work. If I plug in 1, you would get a plus b plus negative 3 equals, no, I'll probably do it another time. All right, so here we'll use vertex form. Okay. So a times x minus h squared plus k. All right, so what they're giving us is the vertex where h is 1 and k is negative 5, right? Here's your hk. So plug those in for h and plug it in for k. Which means I'll get a times x minus 1 squared plus negative 5. Okay, now clean it up, and I get f of x equals a times x minus 1 squared minus 5. All right, so the first thing we're going to look for is, what is the value of a? And to find that, well, we use that other piece of information. It says you have a y-intercept at -3. You have a y-intercept at -3. That means that since my y-intercept is at -3, that gives me the point 0, -3, which means we use the same process as we did in the beginning. This gave us a point. What did we do? We plugged it into the vertex form. Now this gives me a point, but more so of a point in the form of xy. So what I'm going to do is take 0 and plug it in for x. I'm going to take -3 and plug it in for all of y, which is f of x. Feel like a football coach. We're going to do here, 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 and here, okay? So this means we'll first start off by plugging in 0. And then simplify. That's -1 squared, which is just 1. So you'll be left with a minus 5. Okay, and then another thing we know is that when x is 0, y is -3. So this will replace f of 0. So this means that this becomes -3 equal to a minus 5, and therefore a is 2. All right, we found a, which means let's go ahead and plug it back into the vertex form that we have and fill in the value for a. So we are going to get f of x equals 2 times x minus 1 squared minus 5. And to get from this form, to get from vertex form back to standard form, all we have to do is FOIL everything out, and this will give us the values for a, b, and c. So you get 2 times x minus 1 times x minus 1 minus 5, then 2 times x squared minus 2x plus 1 minus 5, and then 2x squared minus 4x plus 2 minus 5, and we get 2x squared minus 4x minus 3. Where a is 2, b is -4, and c is -3. All right, there you go. Not bad, right? Last one. Determine the quadratic function whose vertex is -2, 6, and whose point on the graph is -4, -2. This is no different than what we just did above, but we don't have to label A, B, and C at the end. We would just have to finish by boxing our answer like I did above. So that's all it wants. Same exact process. Start with the vertex form. F of x equals a times x minus h squared plus k. Plug in the vertex. Plug in your hk. A times x plus 2 squared, because if you plug in the negative 2, it'll become positive, and k is k, so k is going to be a positive 6. Okay, and now use the point to plug it in. So this means that we'll have, when I plug in negative 4, I'll get, I'll just say here, the point negative 4, negative 2. So this means you'll get f of negative 4 equal to a times negative 4 plus 2 squared plus 6. So we plug in negative 4 for all the x's. Simplify. Equals a times negative 2 squared plus 6. Now remember that when x is negative 4, y is negative 2. So this means that f of negative 4 becomes negative 2. And this will give me 4a plus 6. Move the 6 over. Negative 8 equals 4a. And divide by 4. A equals negative 2. Okay, and just like the last one, fill in the value for A and FOIL everything out. X squared minus 8x minus 8 plus 6, and negative 2x squared minus 8x minus 2. There it is. That's what we're looking for. That's all it wants. It wants to know the quadratic function. All right. I plugged in negative 4. You will get 16. You will get negative 32, positive 32. Okay, perfect. Just checking my work. Plugging the number in. All right, guys, and that's it. That is quadratic functions. Lots and lots of information, right? Oh, hey, it froze at the end. Okay. Well, oh, there we go. Catching up. All I did was scroll up, nothing different. Okay, that's quadratic functions. Till the next one.